So, what happens when an AI gets so powerful that it actually becomes a security risk? Well, that's exactly the challenge with OpenClaw, which is this incredibly capable AI agent. Today, we're going to dig into a really clever solution designed to control it, the OpenClaw Secure Stack. Honestly, it's a masterclass in how to make these advanced AIs safe enough for all of us to use.
Okay, so what is OpenClaw really? At its heart, it's a super powerful AI assistant. But that power, it's a classic double-edged sword. Its greatest strength, its amazing versatility, is also its single biggest vulnerability. And that forces us to ask a really important question. How do we use all these incredible capabilities without, throwing the door wide open to massive security threats?
The secret to OpenClaw's power, and also its risk, comes from its ability to install third-party plugins, which it calls skills. Just imagine giving your AI the green light to download and use pretty much any tool it finds on the internet. Now, that sounds awesome, right? But it also means you're running code from complete strangers on your own systems. That is a huge security red flag, and that's exactly where the trouble starts.
Look, when you decide to self-host an AI this powerful without the right safeguards, you're not just opening a door, you are taking the entire door right off its hinges. The engineers behind the Secure Stack found 5 critical vulnerabilities that basically anyone running a standard OpenClaw instance would be facing from day one. Let's break down what they are. So this table lays out the 5 core threats. First up, you've got malicious skills. Think of these like Trojan horses, plugins that look helpful but are secretly designed to totally compromise your system. Second is prompt injection, which is a really clever trick to fool the AI into ignoring all of its safety rules. Then there's unauthorized access, a massive risk. That means basically anyone could start using your AI, and maybe more importantly, your expensive API credentials. Next, we have data exfiltration, which is when a skill just secretly sends your private files to some random server on the internet. And finally, without an audit trail, you would have no idea any of this was happening until it was way too late.
Okay, so you're facing these really serious risks. How in the world do you solve this? Well, the answer is the OpenClaw Secure Stack. It's this hardened deployment wrapper, and it's built to neutralize all 5 of those threats we just talked about. And you know the most elegant part of this whole thing? It manages to do all of this without changing a single line of OpenClaw's own code.
The whole idea here is built around what's called a security sidecar wrapper. The easiest way to picture it is like having a highly trained bodyguard standing right in front of OpenClaw. It's technically a reverse proxy, and it intercepts every single request coming in and every response going out. It inspects everything, enforces all the rules, and only lets the safe stuff get through. Meanwhile, OpenClaw itself is totally untouched, completely unaware that it even has a security detail.
Now, this isn't just one bodyguard, it's an entire security team. It's a concept we call defense in depth. It all starts with container hardening, which secures the environment the AI lives in. Next up is network isolation, which stops the AI from talking to any unauthorized servers. Then authentication, make sure that only you and other approved users can get in. Input validation, cleans up all the user prompts to shut down those injection attacks. Static analysis, proactively scans plugins for any malicious code before they can ever run. And finally, audit and observability creates this super detailed log of every single action, so you have full transparency.
And here's where you can see how it all fits together perfectly. This slide just maps each specific threat directly to the defensive layer that stops it. So for example, those malicious skills we were worried about, they get caught by layer 5, the static analyzer. Prompt injection, that's stopped dead by layer 4's input validation. And notice how something like data exfiltration is handled by 2 layers, network isolation and the scanner? It's just a brilliant example of how overlapping defenses can create a system that's truly robust. You know, a really core principle of this whole setup is that it's fail-closed by default. What that means is, if any security check fails, or if there's even a hint of uncertainty, the default response is always to block the request. It's basically the digital version of, when in doubt, the answer is no. This one simple rule is absolutely fundamental to building systems that are genuinely secure. All right, so if we take a step back, what can we really learn from this whole architecture? I think it's a powerful reminder that as we all rush to adopt these amazing new AI tools, we just can't afford to ignore the security side of things. Building a secure foundation isn't some optional extra, it's an absolute necessity. So, what are the big lessons here? First, it's simple. A powerful tool requires powerful security.
Second, that sidecar model is a total game changer for adding security without having to mess with the core application. Third, for these complex modern threats, a multi-layered defense-in-depth strategy isn't just nice to have, it's completely essential. And finally, the most important lesson of all, security isn't just another feature you tack on at the end. It has to be the foundation from the very beginning.
And all of this really leaves us with one final, pretty important question to think about. We're all integrating AI into our lives and workflows at this breakneck pace, but it's probably worth pausing to ask yourself, are the AI tools you're using every single day truly secure? Something to think about. Thanks for tuning in.